Assalamualaikum warahmatullahi wabarakatuh. So today our group will present our Part B project signal conditioning for measuring recoil force in a high caliber gun. There are some problems in our project that will require signal conditioning. The first problem is the output voltage that is produced by the strain gauge is very small. The strain that is measured by the strain gauge is small, therefore it will give out a small voltage output when given a big excitation voltage. Hence, we needed an amplifier in order to boost the signal level, which will increase the measurement resolution and also improve signal to noise ratios in order to get an accurate reading from the strain gauge. The second problem is there is too much temperature change. Any change in temperature will cause the strain gauge to contract or expand depending in which part position it attached to. In a high caliber gun, the strain gauge material used is a metal, whereby the elongation of the metal will influence by the sudden increase in temperature caused by the explosion of gunpowder. Therefore, changes in temperature will cause changes in resistance since the strain gauge is affected by temperature. These two factors need to be properly compensated so that the measurement that is given out is accurate.
Signal conditioning method. Based on the problem occurs, we choose amplifier as our signal conditioning method. There is a lot of type of amplifier and we decided to choose differential amplifier as our amplifier. This is because a differential amplifier can multiply the voltage difference between two inputs by some constant factor, the differential gain. Through this, the voltage can be amplified so that it will be more accurate. Furthermore, it can filter out the common unwanted signals. A differential amplifier tends to reject the part of the input signals that are common to both inputs. For example, temperature change and disturbance from outer environment. Moreover, differential amplifier can also boost signal level to increase measurement resolution. It can also improve the signal to noise ratios.
I will continue about the signal conditioning circuit. I will explain how this circuit works. So as you can see, this is the full whetstone bridge attached to the differential amplifier. So for the stage 1 is a full whetstone bridge, and for the stage 2 is the differential amplifier. So here I'll explain about the how to calculate the VA, which is at the whetstone bridge. So the formula is V1 times with R2 over R2 plus R1. Then for the VB is V1 times R4 over R4 plus R3, because the resistance is in parallel mode. So to for the voltage is applied to the op amp, kita kira guna Ohm's law. I equals to VA minus VB, because there is difference in voltage reading here. Bahagi dengan R5 plus R7 dekat area differential amplifier ni, dekat resistance tu. So the same current flow will flow through resistance 6 and R8. So kita akan dapat kira dekat dia punya V out, which is R6 plus R8 kali dengan I, which is we apply Ohm's law here. Okay, so I've explained about the circuit just now and how to calculate the output voltage. Okay, now I will explain about why we use differential amplifier. So as we know, a full bridge Whetstone bridge is attached to differential amplifier. So we attach it so we can amplify the output value. So that's the purpose. And then the full bridge Whetstone bridge, as we know in the theories, it consists of 2 active strain gauge and 2 dummy gauge. And as we know, the active strain gauge will measure the strain value, whereas dummy gauge will compensate the temperature. So we know that the strain gauge will affected by the temperature fluctuations, so the resistance will change when there is a temperature change in it. So this method has been developed for the manufacture of a temperature compensation element to connect in a Whetstone bridge adjacent arm. This is to compensate the temperature, to give it well compensated and give out an output signal. So for the expected result of the output output voltage is going to be higher, the value, and the value is more precise compared to before we attach the amplifier as signal conditioner. So the reason why we use the differential amplifier is because the differential amplifier will amplify the output voltage, since if we don't attach the differential amplifier, the reading of the voltage will be very small to be read. Therefore we use the amplifier to amplify the output voltage. And also the differential amplifier has a common mode rejection to filter out the unwanted signal that we don't want, especially like the disturbance from the outside. So we don't have to put any filter since it have the CMR in it. So the only I will explain until here. I hope you guys understand all the explanations from my members, and hope you guys enjoy this video. Thank you.